Lesson 4, Common Emitter, Base, Collector Amplifiers. Section 4.1. Measures of amplifier performance. This is an amplifier where Zs is the internal impedance of the signal source. The directions of voltages V1 and V2 and currents I1 and I2 are defined as in this figure. The voltages and currents are AC components and represented by complex numbers. The input impedance is defined as V1 over I1, denoted by Zi. The voltage gain AV is defined as V2 over V1. The current gain AI equals I2 over I1. The output impedance is the measure for the current negative I2, forced to flow by V2. For obtaining this measure, Vs is short-circuited, and Z2 is removed. In other words, Vs equals 0, and Z2 is infinite. Then the output impedance ZO is V2 over negative I2. Section 4.2. Common Emitter Amplifier. This figure shows the definition of common emitter connection. The emitter is connected to the line common to both the input and the output. This defines common base connection. The base is connected to the line common to the input and the output. This is the definition of common collector connection. The collector is common to both the input and output. This is a common emitter amplifier which you learned in lesson 2 and 3. According to the definition of current directions in section 4.1, the base current IB corresponds to I1, and negative IC to I2. The correspondence of the voltages are VBE to V1, and VCE to V2. This is the equivalent circuit of this common emitter amplifier. The voltages and currents are represented by complex numbers. Using this equivalent circuit, let's derive the performance measures for this amplifier. For simplicity, let's neglect the output conductance HOE. The resistance 1 over HOE is very large, compared to RL. This is the simplified equivalent circuit. From this circuit, the input impedance, or in this case, the input resistance Ri is V1 over I1 equals HIE. V1 equals HIE IB. V2 equals RLI2. And I2 equals negative HFE IB, so V2 equals negative HFE RLIB. Thus, the voltage gain AV is obtained as negative HFE RL over HIE. I2 equals negative HFE I1. Thus the current gain AI equals negative HFE. For deriving the output impedance, Vs is short-circuited, and RL is removed. Then I1 becomes 0, because no voltage is applied to the input circuit. Thus I2 is also 0. The output resistance is infinite. Exercise 4.2. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.